lesson will deal with parallel lines and proportional parts. The objective is how do we use proportional parts of triangles to solve problems. So with triangle proportionality theorem, the theorem states that if UV is parallel to RT, then SU over UR is equal to SV over VT. So this is dealing with proportional parts in triangles. And this happens when you have parallel lines. So the piece, this one piece is over the second piece of one side. It will be in proportion or equal to the piece of the other side over that second piece of the other side. So the converse means the opposite, which is if SU over UR is equal to SV over VT, then the two lines VU and RT are parallel. So that's what the triangle proportionality theorem states. And this occurs when you are dealing with parallel lines and proportion. So we're going to do problems dealing with that, so that way you can get a clear understanding of what is going on and how the theorem is put to practice. So they said in triangle EFG, HL, and FE are parallel. And you can see that because of the little arrowheads on both of those lines. So they say EH is 9, so I'm going to mark 9. HG is 21. FL is 6. And they said find LG. So that's going to be X. Since HL is parallel to EF, what proportions can we write? So remember, if those two lines are parallel, then we can set up a proportion. So I'm going to first mark this, so then I know this is with this side. And I'm going to use yellow with this, and then this is the same side with this. So the proportion that I will set up is 9 over 21 equals 6 over X. So this piece to this big piece equals this little piece on this side equals to this big piece on the other side. And if we go back, that's how it was set up. We had the purple to the blue of this side, the right triangle, the right side, and then we have the left side and then the right side. So now once we set it up, then we have 9x, and then this will be 126. And then we can solve for x, which is 126 divided by 9, gives us 14. So that means that LG is equal to 14. Okay, and to see, I'm trying to see if this, once you set up the proportions and solve, there should be a way to check this. I'm just playing around with this one. So this one's 30, and this is 20, and 10. All right, so basically you just set it up. Anytime you see the parallel lines, and you just set up the proportions. And in the converse, remember that if we stated that the proportions, the proportions that you set up are equal, then that means the lines for the base of the triangles are parallel. So they said that HMK and HMK, HM is 15. So I'm going to use colors for that. So this part is 15, and HN is 10, so this little piece is 10, and HJ is, I'll use purple for that, is twice the length of JK. So JK, that means if this length is twice the length of JK, we don't know what JK is, so we're going to put X, and then this one is going to be 2X, because it's twice the length of whatever JK is. So they say determine whether NJ is parallel to MK, and in order for NJ to be parallel to MK, what proportion must be true? So then we have to set up the proportion. Now, there's different ways to do this, and I'm going to use the blue. Different ways to set this up. Okay, there. We have this overall length for this one side. Oops, why is this doing that? All right, so we have let me make sure I have I'm on the right thing. So we have this overall length for this side, but if we need the overall length for MK, for HK, it would be X plus 2X, and I'm just gonna put that there. Basically, you're just adding up those two sides and you get 3X. And then you could try to find the proportion. Or you could subtract 10 from 15 and then you can get your 5 here. So that way you wouldn't have to add up those two. But either way, as long as everything is set up and it's in proportion, then we're trying to prove that those two lines, NJ and MK, are parallel. So for this one, we will have 10 over 5, and then this would be 2X over X. So then we would cross multiply, and I know you would have the urge to try to solve for X, but look at what's happening. Look what's happening. This side says 10X, this side says 10X. So what does that tell you? That tells you that yes, that NJ and MK are parallel, because we proved it by setting up the proportion, and it shows that the two sides are equal, so that way these two lines are going to be parallel. So again, we're using the converse in order to prove that the two lines are parallel to make this whole triangle, the two triangles, similar. All right, let's go on to the next. Next one is proportionality corollaries. So they're giving us two corollaries. The first one says 2 or more parallel lines create proportional parts. We were working with 2 parallel lines, but if you have 2 or more, it will create proportional parts. So that means AB over BC will be equal to XY over YZ. So this portion congruent to this portion. And then AC over AB will be equal to XZ over XY. So again, you just look at how it's set up and then match it on the other side. So that way it's in proportion. And then AC, that means the whole length from that first parallel line to this third parallel line over BC, the first portion of it, will be equal to XZ, that whole side, over YZ. The next one says when 2 or more parallel lines create congruent parts of one transversal, they also create congruent parts on the other transversal. So transversal is basically a line that cuts through parallel lines. We already learned about this with parallel lines and transversal. So let me highlight our transversal. We have, this is our transversal, and this is our transversal. And I'm going to highlight this transversal. And then we have our parallel lines, and I'm just going to put that in yellow, so that way you know what they're talking about. So when two or more parallel lines create congruent parts of one transversal, they also create congruent parts on the other transversal. So that means whatever parts you have on this side will be congruent to the other. So they ask you, what is the length of KL? So I'm going to go select. All right, so we notice that this is 12 and this is 9. This is also 9, so that means that KL will be 12 because we have congruent parts. So whatever's happening on one side, however it's set up on one side, it's going to follow the same pattern as the other. Both of these parts are 9, and based on the corollary, that means the other side with the 12, that piece will also be 12. Again, even if you were to set up a proportion, you would notice that, and I'm just going to show you, because let's see, if we have 9 over 9 equals 12 over what? So when you cross multiply, and this gives you 108, and then you divide, you get 12. So they just proved their point. So again, anytime you have two or more parallel lines, it creates congruent parts of one transversal. It will also create congruent parts on the other side, the other transversal. Okay, move on to the next. So we're going to do problems based on that. So we have 3 parallel lines. We have 2 transversal. So then we know that we have to set up a proportion. So we have 5 over 8, and it's going to equal y over y. Oops, that is not a y, that looks like an x. Let me erase that. So y plus 2. So you're going to cross multiply. I'll do that with the highlighter so that we know what's the next step. You cross multiply. So 5 times y plus 2 equals, I'm messing up here. Okay, let's do this again. 5 times y plus 2 equals 8y. We distribute. 5y plus 10 equals 8y. And then you're going to bring the 10 by subtracting it on both sides. And then 8 subtracted on both sides, you get negative 3y. And then y equals, should just leave it as a fraction anyway. I'll just leave 10 over 3 as your y. Right, so basically, it's in proportion. And just going back, so like they have it here. So AB to BC, and then XY to YZ. Same thing we did here. The 5 over 8, and then y over y plus 2, and then, oops, I made an, actually no, I didn't make an error. That was fine. Never mind. So that is correct. All right, let's go on to the next. So for this one, we have 3 parallel lines. We have 2 transversal. But there's something that is going on here. I'm paying attention. There's a mark here. These marks. It's telling me that this is congruent to this. Because notice how we have y here and then y here. And if you were to set up a proportion, you will have 2 variables and you wouldn't be able to solve. So for this one, I'm going to do these 2 first because these 2 are congruent to each other. So that means I can set them equal to each other. Again, when it comes to looking at diagrams, if they mark something, pay attention. Pay attention to everything that is given. Because sometimes there are clues that are given for you to know how to start to solve the problem. So this would be negative x, and then this will be negative 6. So that'd be x equals 6. So now I'm going to plug it in. So for the first one, I'll plug it in. That gives me a 12. So that's 14. And then this is 3 times 6 minus 4. That's 18 minus 4. That's also 14. So I'm going to put 14 for this side and then 14 for this side. All right. So now, knowing that these two are congruent, that means these two has to be congruent also. And I'm going to use another color for that. And extend this. So that means I'm going to set those two pieces equal to each other. And then I'm going to subtract that. That's negative 7. And then I'm going to have a common denominator. Actually, I'm going to use another color for that. Purple. So that means this will turn into 15 over 3. And then I'm going to simplify. So then that'll be negative 7 over 3y equals negative 7. Extend that. And then I'm going to, in order to move that, I'm doing the reciprocal of that. And actually, I should use consistent, so that'd be negative 3 over 7. And what I do on one side, I do on the other. So I can cancel out. So this will cancel out with that, and I'll have y. This will become positive, this cancels out, and then y will equal 3. Which one did I use? Right. Let me box that. So then again, if I were to plug that in, I should get 15 for both. So that's how you do it. This one was a little bit more involved because you had to also pay attention to the clue. If you were to, you could have set it up, but again, you would have two different variables, and then it would be a hot mess, and you would not know what to do next. You would be stuck. So this is a problem where they give you two, show you that those two pieces on the transversal is congruent, so you can set it equal to each other and then solve. So remember, based on the proportionality theorem with parallel lines, if you have one side, the two parts of the one side is congruent to each other, then the other two parts of the other transversal is also congruent. All right, the next thing is mid-segment theorem. The mid-segment theorem is a line that connects the midpoints of two sides of a triangle. So we've got the side AB and AC, and DE is the middle of this triangle. So it starts from the midpoint of AB and goes to the other side of the triangle to that midpoint. And basically the theorem is the mid-segment is half the length of its base. So that means D, if D is x, then BC is 2x. It's twice. And this is half of the base. All right. So again, we're going to solve. So the base is 35. And this is the midpoint. Why is it the midpoint? Because it's shown that this part is congruent to this part, and then this is congruent to that. That means that it's at the middle. So then all you got to do is 35 divided by 2, and then you get 17 for that. I mean 17.5. So that means, yeah, x equals 17.5. Next one, so given that BC measures 54, so I'm going to put 54, find the measure of DE. So that means it's going to be half. So this 54 divided by 2 will give you 27. So that means DE is equal to 27. nothing to it. If they tell you that it's the mid segment of the triangle, you just find out what the base is and do divided by 2. If they gave you the measurement for the mid segment, then you need to double it to give you the base. So be careful with that. All right, so we've reached our end. We've learned quite a few things in this lesson. So I'm just going to do a recap. So the first one we learned was the triangle proportionality theorem. Basically, it's saying that if there's two parallel lines, then the one side, the pieces of the one side is going to be equal to the two pieces of the other side. And the converse is basically if the two pieces of one side is equal to the other two pieces of the other side of the triangle, then the lines, the base is parallel. And then we also learned about the corollaries with parallel lines and transversal. So if you have more than two parallel lines, then they're going to create congruent parts on one side of the transversal, and it's going to be the same on the other side, other side with the other transversal. And the mid-segment theorem, all they're telling you is that the mid-segment is located halfway of the triangle, where the two ends meet with the middle of each side of the triangle, and it's half the base. And if they gave you the mid-segment measurement and they ask you for the bottom part of the triangle, the bottom base, then that would be double. All right, so like I said, it was a lot in this lesson, and if you have any questions, you know the drill. Email me and I'll help you out by giving you more examples and more clarity. All right, this ends our lesson, and have a good day.